All right, I just wanted to work a couple of stoichiometry problems or allow you to work these for review. Depending on where you are in the lesson, 4.06, you may want to use these as a guide or you may want to use these as a review. Feel free to jot down this question, pause it, and try to work it on your own and then restart just to check your answers, or just follow with me as I work the problem. Now, some things that we need to know ahead of time is just kind of some masses from the periodic table. Boron has a mass of 11 grams. Hydrogen has a mass of 1 gram. And you can see some of my stuff is cut off here. That's supposed to be a BH. And then oxygen has a mass of 16 grams. And that's information from the periodic table. That's the atomic mass of each one of those different elements. Now, remember in stoichiometry, very first thing we need to do is balance the equation. That's essential. Starting with the boron B, there's 2 on the left side. There's 1 on the right, so I'm going to put a 2 in front of this. Needed a little bit more space in there, but that's okay. Hydrogen, I'm going to check my hydrogens. There's 6 on the left side, and sometimes when an element's by itself, you want to leave it till the last because you can adjust it easier. So there's 6 hydrogens on the left side. I have 2 from this compound, so I have 4 total right now. If I change the water to make it 4 hydrogens, then I have 4 plus 2, I have 6 hydrogens now. So I'm left with my oxygens. That did not change the borons. I have 2 times 2 is 4 oxygens plus another 2, so I have 6 oxygens on the right side. And to make that 6, I just put a coefficient of 3 in front of the oxygen. So now I have a balanced reaction. That's the very first thing you need to do when working any stoichiometry problems. Now, we have 2 problems we're going to work. The first one, what mass of oxygen will be needed to burn 36.1 grams of B2H6? Remember that you start with what's given in the problem. So we're going to start with the 36.1 grams B2H6. And also remember to write the units, whatever you're working in, and the substance all the way through just to see that things are crossing out and making sense to you. Okay, we're going to set up our chart. Now, in this case, we've got to change substances. We've got to go from B2H6 to O2. To do that, the only way to do that is mole to mole. So we've got to get grams of B2H6 to moles of B2H6. I'm going to write grams on bottom because it's written on top. That way it will cross out. And then I'm going to convert to moles of B2H6. In every 1 mole, there are 28 grams. And I just calculated that using my periodic table. I've got 11 plus 11, which is 22 borons, 6 oxygens, or 6 hydrogens rather, so that gives me 28. Now the grams are gone and I'm left with moles. This next step then I can go from moles to moles and I can change substances. B2H6 to moles of oxygen. When you're looking at mole to moles, you use the mole to mole ratio that was given in your balanced equation. So I come up here and I look at oxygen. What coefficient is written before oxygen? It's a 3. So I'm going to have, for every 3 moles of oxygen, I'm producing, or I need rather, 1 mole of B2H6. So it's a 3-to-1 ratio. Now, it did ask for the mass of oxygen, so I have to go one more step. Now, I got rid of my B2H6, and I've got to go one more step to convert from moles of oxygen to grams, the mass of oxygen. And in every 1 mole, there's the molar mass from the periodic chart. There's 2 oxygens, so 16 times 2 gives me 32. Now then the last step, since I am left, my moles of oxygen are gone, I'm left with the correct unit and substance, grams of oxygen, that's what I was asked to find. All I do now is multiply by everything on top. So 36.1 times 1 times 3 times 32. And then divide that by what's on bottom. And essentially you have 28. When I do all my math, I get 123.8 grams of oxygen. Okay, so that's the first problem. That was part A. Part B asked a different question. How many moles of water are produced from 19.2 grams of B2H6? So again, we start with what's given in the problem, 19.2 grams B2H6. This one's going to start pretty similar to the last problem in that we need to get to moles because we've got to switch substances. So grams B2H6 to moles of B2H6. And every 1 mole, there's 28 grams, just like we saw above. Now I can go to a different substance because I am in moles. So moles of B2H6. In this case, we're going to go to moles of water. Come back to your balanced reaction. What coefficient is in front of water? Well, we have a 2. And our B2H6 had a 1 coefficient. Now, this is done. This problem asks you to go to moles of water rather than grams of water. So we have moles of water. We can leave off that last step. Take your 19.2, multiply it by 1, multiply it by 2, and then divide by 28, which was on the bottom. And when you do all that, you get 1.4 moles of H2O. Okay? So that's just a couple of stoichiometry problems. If you have any questions, feel free to ask. You can email me, you can call me, or you can ask in live class. So I hope this helped, and thank you.